Welcome and thank you for joining the presentation on personalized anchors. We, that is Oliver Müller from the Paderborn University, Markus Weinmann from the Rotterdam School of Management, and me, Kevin Bösch, a PhD student at the Paderborn University, have conducted the study on when one size fits most, static and personalized anchors for retirement savings. This study is about a topic that should concern most of us, retirement savings, especially because we are in midst of what sometimes is referred to as the retirement savings crisis. This is because 50% of US households are at risk of being unable to maintain the standard of living that they're having now. This is most of the time not due to economic reasons, but because how decisions on retirement savings are made. There are two fundamental assumptions when it comes to retirement savings planning. The first one is that everybody has the cognitive ability to calculate optimization problems for retirement planning, meaning to find the optimal asset allocation and the optimal monthly premium. The second one is to execute this retirement savings plan, which needs a lot of willpower because these are long-lasting decisions. In order to help people making good retirement planning decisions, nudges have been developed. These are small interventions that build on the findings of behavioral economics. Three that have been proven successful are automatic enrollment, automatic investments, and automatic escalations. However, these nudges are most of the time one-size-fits-all approaches, meaning that the heterogeneity of customers is not taken into considerations. Secondly, new applications, web apps, digital products allow for a tailored nudge, meaning based on the collected data, personalized offerings can be developed and we can shift away from one-size-fits-all approaches to personalized nudges. One of these nudges are anchors. Anchors are about the insufficient adjustment when exposed to a pre-selected, most of the time arbitrary value. This means that the initial information that is provided as the anchor leads to as the starting point and an insufficient adjustment towards their actual preferences. This anchoring effect has proven to be robust across field and lab experiments, such for example, M&A premiums, contribution rates in retirement savings planning, or forecasting on equity markets. When it comes to personalization, this has been a topic even before the term of nudging has been introduced. Personalization has shown that products are more enjoyable, but also more effective when they are personalized, as opposed to one-size-fits-all approaches. When it comes to anchors and personalization, there is one lab study that showed that if there are personalized anchors that are manipulated upwards or downwards, people adjust to their actual preference. This adjustment is defined as the absolute difference between the exposed anchor and the selected payment. This will also serve as a construct for our later analysis. To this extent, we tried to find out whether personalized anchors affect high-stake retirement decisions. In order to shed a light on this interesting topic, we have teamed up with a fintech called Prosperity.app. There we have collected 91 high-stake decisions conducted in their digital product. For the personalized anchor, we have applied a random forest regress that was built on the demographics of the customers and also about product configurations. We have randomly assigned the customers into three distinct groups. The first one is a static low anchor of 0. The second one is a static mean anchor of 5,500. These two conditions are one-size-fits-all approaches. The third condition is a personalized anchor that was, as previously mentioned, built on this random forest regress. However, the static mean anchor and the personalized anchor share the arithmetic mean of 5,500 in order to be comparable among the conditions. In order to find out how personalized anchors affect decisions, we are interested in two effects. The first one is, do personalized anchors lead to lower adjustment, meaning the absolute difference between exposed anchor and selected payment? And the second one is, whether personalized anchors lead to higher investments. To analyze this effect of our treatments on either adjustment or investment, we have used a multi-level model with varying intercepts representing our conditions. In addition, we have estimated the contrasts between the conditions in order to test the differences and their significance. Looking at the application, we see that if a customer logs in, he or she is able to make an additional payment by clicking on the deposit money button located in the center. When clicking on this button, the user is redirected to a second screen where he or she enters the desired amount that should be invested into their retirement fund. Depending on the assigned condition, an anchor in this text field is shown. First, for the static low anchor, a 0 is displayed. For the static mean, a 5,500 value. And for personalized anchors, a personalized anchor is shown. Now looking at the result without the model yet, we see that for adjustment, users adjust approximately 800 Swiss francs towards their actual preferences. For personalized and for mean anchors, we see that a lot of customers do not adjust the anchor at all. When it comes to payment, we see a range between 100 and a maximum of more than 10,000. So we see this is kind of a high-stake decision that people need to make. Now looking at the results of the model, we have estimated the contrast between the different conditions. First, let's look at the adjustment. We see that there is no difference between mean and low. We see there is in the textual representation of the estimates, we see that there is almost no difference in adjustment between the mean and the low condition group. Now between the personalized group and the low group, as well as the personalized and the mean group, we see a significant adjustment based on the 95% credibility interval that people exposed to a personalized anchor adjust less than a one-size-fits-all anchor of either low or a mean anchor. When it comes to payment, we see that the mean anchor, being 5,500, leads to higher payments than a low anchor of 0. This is in line with previous research on the anchoring effect. For personalized versus low and for personalized versus mean, we find no significant effect. Especially for personalized mean, this is obvious as these two groups share the same arithmetic mean of 5,500. So we expected to find no influence of personalized anchors compared to mean when it comes to payments. Based on these results, we conclude that for personalization, we find an effect, meaning that the adjustment, meaning the absolute difference between exposed anchor and selected value, is lower for personalized anchors as opposed to one-size-fits-all approaches. This leads to a reduction of risk of exposing users to inappropriate anchors, potentially backfiring in churn or other negative effects for the company. Secondly, we find additional support in high-stake decisions for the anchoring adjustment heuristics, because higher anchors lead to higher payments, as we have seen in the comparison between the mean static group and the low static group. Finally, we conclude that with the combination of personalized anchors, we can help customers make better decisions in retirement savings, meaning higher investments, but at the same time taking their heterogeneity into account. We thank you for listening to our presentation, and we are very much looking forward to your feedback. Thanks.